Service drop sizing. If the local utility requires a single service drop for the duplex at 200 amps total, the service drop wires must be sized based on 200 amps. This ensures that the wires can safely handle the combined load of both units. For service conductors from the meter to the main panels, a load calculation can be performed to determine the minimum size of conductors needed from each meter to the respective main panels. This is because the load calculation considers the actual electrical demand of each unit. Based on the information provided, a 100 amp service for each unit should be sufficient. Using a load calculation, the following conductor sizes may be appropriate. For a 100 amp service, use number 2 copper or number 2 aluminum. However, some utilities may have specific requirements for conductor sizing, so it's best to consult with the local utility before making a decision. For recommended wire sizing for the service drop, use 2/0 copper if required by the utility. For service conductors from the meter to the main panels, use number 2 copper or number 2 aluminum, subject to load calculation and local utility requirements. Consider future expansion. If there's a possibility of adding additional electrical loads in the future, consider upsizing the service drop and conductors accordingly. Always consult with the local building code to ensure compliance with all applicable requirements. Let's talk more about electrical service upgrades specifically for a duplex, and delve into the considerations for wire sizing according to electrical codes and best practices. The scenario involves upgrading each unit of a duplex from a 60 amp service to 100 amp service. This upgrade necessitates careful planning and adherence to electrical codes like the National Electrical Code, or NEC, to ensure safety and compliance. The initial question revolves around whether the service drop, which is the connection from the utilities lines to the building, needs to be sized based on the total amperage of the upgraded service, which would be 200 amps, or if a load calculation can be used to determine a smaller, potentially more cost-effective wire size. To address this, we must first understand the role of the utility company. The utility company's requirements often dictate the minimum size of the service drop conductors. If the utility mandates a single service drop capable of handling the combined load of both units, then sizing the wires for 200 amps is mandatory. This requirement ensures that the utility's infrastructure can safely deliver the necessary power to the duplex. However, when it comes to the service conductors that run from the meter to the main panels within each unit, a load calculation can indeed be used to determine the appropriate wire size. A load calculation assesses the actual electrical demand of each unit, taking into account factors such as the square footage of the unit, the appliances installed, and the anticipated usage patterns. The NEC provides guidelines for performing load calculations, which involve adding up the various loads within a dwelling unit and applying demand factors to account for the fact that not all appliances and electrical devices will be operating at their maximum capacity simultaneously. Based on the information provided, each unit is a one-bedroom apartment of approximately 800 to 900 square feet, with an electric dryer in the basement and a few window air conditioning units. All other major appliances are gas-powered. This suggests that the electrical load is primarily for lighting, small appliances, the electric dryer, and the air conditioning units. Given these characteristics, a 100 amp service for each unit may indeed be sufficient. To determine the appropriate conductor size for the 100 amp service, NEC Table 310.16 can be consulted, which provides ampacity ratings for various conductor sizes based on their insulation type and installation method. For copper conductors with a 75 degrees Celsius insulation rating, which is commonly used in residential wiring, a number 2 copper conductor is typically rated for 95 amps. However, it's crucial to ensure that the terminations, such as breakers and lugs, are also rated for 75 degrees Celsius. If the terminations are only rated for 60 degrees Celsius, the ampacity of the conductor must be derated accordingly. Similarly, for aluminum conductors, a number 2 aluminum conductor with a 75 degrees Celsius insulation rating is typically rated for 75 amps. Again, it's essential to verify the temperature ratings of the terminations and derate the ampacity if necessary. Therefore, number 2 copper or number 2 aluminum conductors may be suitable for the 100 amp service, but the final determination should be based on a thorough load calculation and consideration of the termination temperature ratings. It's important to note that local utilities may have specific requirements for conductor sizing that are more stringent than the NEC minimum requirements. Therefore, it's always best to consult with the local utility company before making any decisions about wire sizes. In addition to conductor sizing, other factors must be considered when upgrading an electrical service, such as the size of the main disconnects, the grounding and bonding requirements, and the overcurrent protection devices. The main disconnects, which are typically circuit breakers or fuse switches, must be sized appropriately to protect the service conductors and the electrical equipment within the unit. The grounding and bonding system must be properly installed to ensure that the electrical system is safely grounded and that any fault currents are safely conducted back to the source. The overcurrent protection devices, such as circuit breakers and fuses, must be sized to protect the conductors and equipment from overloads and short circuits. When selecting conductors, it's important to consider the material, size, insulation type, and installation method. Copper and aluminum are the two most common conductor materials used in electrical wiring. Copper has a higher conductivity than aluminum, which means that it can carry more current for a given size. However, aluminum is lighter and less expensive than copper. The size of the conductor is determined by its ampacity, which is the amount of current that it can safely carry. The insulation type is determined by the voltage rating of the conductor and the environmental conditions in which it will be installed. The installation method is determined by the type of wiring system being used, such as conduit, cable, or open wiring. In the specific scenario presented, the plan was to use 2/0 copper conductors from the service point to the meter pans and then number 4 copper conductors from each meter to the main panels. While this plan may be acceptable, it's important to verify that the conductor sizes are appropriate for the actual electrical load and that they comply with all applicable codes and regulations. If a load calculation reveals that the actual electrical demand is less than 100 amps per unit, then smaller conductors may be used. However, it's generally a good practice to oversize the conductors slightly to provide for future expansion and to minimize voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or to fail prematurely. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. In addition to the technical considerations, it's also important to consider the practical aspects of working with different conductor sizes. Larger conductors are more difficult to bend and terminate, which can make the installation process more challenging. Therefore, it's important to choose conductor sizes that are both safe and practical to work with. In conclusion, upgrading the electrical service to a duplex requires careful planning and adherence to electrical codes and best practices. The size of the service drop conductors is typically determined by the utility company's requirements, while the size of the service conductors from the meter to the main panels can be determined using a load calculation. It's always best to consult with the local utility company and a qualified electrician before making any decisions about wire sizes or other electrical system components. By following these guidelines can ensure that the electrical service upgrade is performed safely and efficiently. Let's delve deeper into the specific considerations for this duplex upgrade. The neighbor's request to increase each unit's service from 60 amps to 100 amps suggests in anticipation of increased electrical demand. It's important to understand the reasons behind this request to properly assess the load requirements. Are there plans to add more appliances, upgrade existing ones, or install energy-intensive equipment? Understanding the future electrical needs is crucial for accurate load calculation and wire sizing. Firstly, performing a detailed load calculation for each unit is paramount. This involves itemizing all the electrical loads, including lighting, receptacles, appliances, and any other electrical equipment. The NEC provides specific methods for calculating these loads, taking into account demand factors that reflect the likelihood of simultaneous operation. Secondly, considering the existing infrastructure is essential. The existing meter enclosure and main panels may need to be upgraded to accommodate the increased amperage. It's important to ensure that the new equipment is compatible with the existing wiring and that it meets all applicable safety standards. Thirdly, consulting with the local utility company is crucial. The utility company may have specific requirements for service upgrades, including the type of service entrance equipment, the location of the meter, and the grounding and bonding requirements. They may also require an inspection of the completed work to ensure compliance with the standards. Fourthly, obtaining the necessary permits is mandatory. Electrical work typically requires permits from the local building department. The permit process ensures that the work is performed by qualified individuals and that it meets all applicable codes and regulations. Fifthly, hiring a licensed electrician is highly recommended. Electrical work can be dangerous, and it's important to have it performed by someone who is qualified and experienced. A licensed electrician will be familiar with the NEC and local codes and will be able to ensure that the work is done safely and correctly. Sixthly, choosing the right type of wiring is important. Copper and aluminum are the two most common types of wiring used in residential electrical systems. Copper is more conductive and durable than aluminum, but it is also more expensive. Aluminum is lighter and less expensive than copper, but it requires special installation techniques to prevent corrosion and overheating. Seventhly, selecting the appropriate size of conduit is necessary. Conduit is used to protect electrical wiring from physical damage and moisture. The size of the conduit must be large enough to accommodate the wiring and to allow for future expansion. Eighthly, ensuring proper grounding and bonding is critical. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault currents to flow back to the source, while bonding ensures that all metal parts of the electrical system are electrically connected. Ninthly, installing surge protection is advisable. Surge protection can protect electronic equipment from damage caused by voltage surges. Surge protection devices should be installed at the service entrance and at individual outlets where sensitive electronic equipment is used. Finally, documenting the work is essential. A detailed record of the work performed, including the materials used, the wire sizes, and the equipment ratings, should be kept for future reference. This documentation can be helpful for troubleshooting problems and for future electrical work. In the specific case of the duplex upgrade, the following steps should be taken. Firstly, determine the total load for each unit by performing a detailed load calculation. This should include all lighting, receptacles, appliances, and other electrical equipment. Secondly, consult with the local utility company to determine their requirements for service upgrades. This may include the type of service entrance equipment, the location of the meter, and the grounding and bonding requirements. Thirdly, obtain the necessary permits from the local building department. Fourthly, hire a licensed electrician to perform the work. Fifthly, select the appropriate type and size of wiring for the service upgrade. Sixthly, install the new service entrance equipment, including the meter enclosure, main panels, and circuit breakers. Seventhly, ensure proper grounding and bonding of the electrical system. Eighthly, install surge protection devices at the service entrance and at individual outlets where sensitive electronic equipment is used. Ninthly, document the work performed, including the materials used, the wire sizes, and the equipment ratings. By following these steps, the electrical service upgrade to the duplex can be performed safely and efficiently, ensuring that the residents have adequate power for their needs. Remember to always prioritize safety and consult with qualified professionals when working with electricity. Ignoring this can lead to dangerous outcomes.